All right, should we get started so that I can fit in the time slot, which is going to be difficult, but so it's really great to be back at DNN Connect. It's been since it's at least a couple of years, probably 3 years since I've been at DNN Connect. The last event I went to was in France, which was a fun event, but I've missed the last two, so it's great to be able to connect with all these great folks from Europe. So many familiar faces at this conference that I haven't seen in a while, so it's really great to be able to see you all again. I've talked to a few people just in the last day or so, and I think, so a lot of folks were asking about a new open source project that I've been working on. Originally, when I put together this presentation, it was more focused on the Microsoft technology that's behind it, not necessarily on this new project. I'm going to touch a bit on the new project at the end, but I think it's important for everyone to understand Blazor and what it is and whether or not it might fit in the technology landscape that you're looking at for the future. Because to be clear, it's very new. It just had the experimental tag taken off. It's not a released product yet. And there are some characteristics of it which are very different than traditional web applications. So all of this will be more educational, I think, for some of you. How many of you have heard of Blazor? So probably a lot of people. How many of you have actually played with Blazor at all? No one. Okay, so a little bit. All right. So I am happy that some folks from the DNN community have already reached out to me in regards to the open source project. Like, for example, David, Mitch, others have already even submitted pull requests, which is really cool. So I think there'll be some interest in the DNN community, but I'll touch more on that at the end. So we're going to talk about Blazor today. All of you know who I am based on, I guess, my past history at DNN. I am not a Microsoft MVP anymore. I don't think there's very many MVPs in the DNN ecosystem anymore. Microsoft changed the MVP program and made it more marketing focused. So a lot of us that had been MVPs in the past had lost that recognition. There's a chance, of course, to get back into the program again in the future based on things that we're doing. I am still the chairman of the advisory council for the .NET Foundation. Some of you are probably aware that the .NET Foundation recently went through a big change where they had an open voting for board seats, whereas previously the board had been appointed by Microsoft itself. I actually had put my name forward for a board seat, so had Mitch. Unfortunately, neither of us got on the board, but there were some really good folks that had also put their names forward. So I think that the board is a very diverse board, and I still talk to John Galloway, who's the executive director for the .NET Foundation. I have a weekly meeting with him, and the board is actually making progress on things, so he's quite happy with how it's going. So that's all good. So today I'm going to cover what is Blazor. I'm going to talk a bit about the client-side aspect of it and the server side, because this is kind of a confusing aspect to it. I'm going to go over some of the fundamentals of Blazor in terms of what it offers today. And then I'm going to talk a bit about Oqtane, which is the open source project that I've been building based on Blazor. So what is Blazor? So Microsoft has changed the definition of Blazor since it first introduced this concept. And that's created a little bit of confusion. This latest definition, I think, is more generic because they've realized that the Blazor technology is more applicable to different scenarios than they first imagined. And so they're trying to open up the opportunity so that it could be applied to many different things. But basically, it's a single-page application framework for building interactive .NET Core applications. So this is .NET Core. Where did it all get started? So there was a conference in Europe, NDC Oslo, in 2017 that Steve Sanderson presented at. So Steve Sanderson's worked for Microsoft for a long time. You might be familiar with his name because he was the inventor of Knockout.js. So a lot of us used Knockout in the early days. Even DNN used Knockout. I don't know if he has much Knockout anymore, but Steve invented that JavaScript library, which was very early in what you would consider the single-page application type of model. Knockout predates things like Angular and React and things like that. So he's a pretty smart guy. In this particular session, you can find it on YouTube. It's kind of an interesting session. So he outlined 4 different types of web-based technologies that he thought were going to be very relevant for the future. One of them was service workers and progressive web apps, and one of them was WebAssembly. So what was really interesting about this session, and I don't know how much time he had to prepare for it, is he basically explained WebAssembly at that early stage, but he had already built a working prototype of running a .NET-based application, like a C# application in the browser on WebAssembly way back in 2017. So obviously, he understands this stuff at a pretty fundamental level, and so he was able to make quick progress. But I talked to a few guys from Microsoft at the MVP Summit this past spring, because I guess lucky enough I'm still able to go to the MVP Summit because of some other affiliations that I have. And apparently, so his bosses, so Steve Sanderson is I think he's a senior developer, or like he's not a really highly ranked person within the Microsoft organization. However, some of his managers were at the event. They were also speaking at NDC Oslo, but they didn't know what he was going to speak on. So they were in the audience when he basically presented this WebAssembly thing with .NET running in the browser, and they were basically blown away. They're like, how did he do that? Like, how did he? So that was the spark to start exploring this further. It took all the way until February of 2018 before Microsoft basically said, okay, this is like a real thing. We're going to endorse it as an experimental product. So we're going to apply some real resources to it to see where it can go. But we're not going to say we're going to ship anything. We're just going to start developing it as an experiment. So you can see between like June 2017 and February 2018, probably it was just Steve sort of hacking away on things in his spare time. And sort of trying to work his way through whatever the red tape is to get things approved at Microsoft. But by February 2018, he basically had the approval to move forward with it within the ASP.NET core team. So since then, they've made a lot of progress. So they've been pretty regular with releases, almost releasing something every month. So they've made, since adding resources to the project, they've made pretty good progress over time. Obviously, the most recent release is the 3.0 Preview 5, and they're working on Preview 6 right now. You'll see that the version numbers made a big change after March 7th, where they basically decided that this is a real product. We're going to ship it as part of .NET Core 3 in September. And so after that, they made the version numbers align with the .NET Core release, and it's actually so part of .NET Core now. Whereas before that, it was a separate download that they were developing independently. So so the release schedule going forward. There's a couple more preview releases that they're working on, and they expect to release it as part of .NET Core 3 in September. There's some limitations to what they're actually releasing, which I'm going to cover in a few more slides. So the other thing that happened is in April, they actually came out with an official message from Microsoft saying this is no longer experimental. This is a real product. We're going to actually ship this. There was, like I said, some limitations to it in that they're going to ship a specific variant of it in September, and there still is another type of Blazor which is going to ship a little bit later. But this was good news, like in terms of this experiment getting enough recognition and enough excitement and enough support that they want to move forward with it. So at this point, it's going to ship. It's going to be a real product, but it's still early days. So there's 2 different flavors of Blazor, and this is where Microsoft has created some confusion, because the first information that was shared about Blazor was all very focused on this client-side model. And that's what Steve Sanderson created. That's what the demo was at NDC Oslo. So in some ways, Blazor, the brand name, has become synonymous with running .NET in the browser. But in fact, what Microsoft has since found out is that they've been able to separate the component development model for Blazor from the hosting model. And so basically, you can build a Blazor application, and you can choose a variety of different ways to run it. One way is obviously the client-side model. The model that they're going to actually ship, though, in September is a server-side model, where the client-side model is probably going to ship towards the end of this year. I've heard more likely around December. There are also other hosting models that this Blazor concept supports. Still running or still building things in Razor components, in the same exact way. So there is some confusion. Microsoft is now, they tried to move away and try to brand these two aspects separately. And then they decided that that was a bad idea, and now they've combined them under this Blazor branding. I hope going forward it's going to get more clear to everybody what Blazor is, but I think Microsoft created a whole lot of confusion at the beginning of this. So what is client-side Blazor? So first of all, what it is not Silverlight. It's not like Silverlight Reborn, right? It's something that's entirely different. In fact, if we look at like technologies that were designed to run in the browser, we can go all the way back to ActiveX. Some of us probably remember ActiveX. Then, of course, Flash, Flex, things like that. Microsoft Silverlight, which died a sort of very quick death because of vendor hardware support and things like that. Dart is a project out of Google that allows you to write applications that run natively in the browser. The problem with all of these technologies is that they required you to download and install a plugin. So that created a runtime environment in the browser, which allowed you to build applications that would run within that runtime. But that's exactly the model that, I get, at least because of some of the performance issues that those runtimes would create within the browser, certain hardware vendors eventually said, OK, we're not going to support these types of plugins anymore. And so that was what led to the sort of the untimely death of Silverlight and some other technologies. So where Blazor is very different from this. So Blazor doesn't require a plugin. That's one of the major differences, and that's why it's sort of not Silverlight Reborn. It's something entirely new and different. So WebAssembly is actually not something invented by Microsoft. It's something that was created as an international standard. It's an instruction format for a stack-based virtual machine, which, I mean, that doesn't mean a whole lot. .NET itself is a stack-based virtual machine. But it basically allows you to build a runtime environment that can run in a certain sort of memory space. And in this case, it was designed for the browser. It was originally introduced in 2015, so it's actually been around for a while. And the cool thing, I guess, is if you think about this, it's the very first language since JavaScript that's been designed to run natively in the browser. There is no other language out there other than JavaScript which has this capability. And meaning without plugins, right? So running natively in the browser in the exact sort of binary or byte format that browsers understand. All of the major browsers today support this. So at least all of the modern browsers today support this. So Firefox, Chrome, Edge, and Opera. So they all support WebAssembly today, which means that there's no reason why adoption can't happen, right? There's no technical reason why people can't build applications using WebAssembly, as long as your users are using modern browsers. So how does this actually work, right? So a lot of us have become familiar with writing JavaScript over time. I don't think everyone understands fully how JavaScript really works behind the scenes. So whether it's inline JavaScript in your HTML or whether it's JavaScript as files that are pulled in as resources, they are actually parsed in your browser by the JavaScript runtime. So they are parsed, they're compiled into bytecode, and it's actually the bytecode that the browsers use to sort of refresh your environment. So that's your just-in-time compiler there. That's like dealing with bytecode. So that's exactly how JavaScript is processed. So how does WebAssembly work? Well, the interesting thing is it just plugs in at that lowest level. So WebAssembly can be written, I mean, you can use languages like C, Rust, Go, .NET. As long as you can compile those languages, those higher level languages, to WebAssembly, that WebAssembly can be interpreted by that same interpreter that's part of your JavaScript runtime and used to run your application. So this isn't something that's really groundbreaking, right? There was, I think, always this opportunity to plug things in at that level. So, and the cool thing, too, is you can mix and match. So you can mix an application that uses JavaScript with WebAssembly, and they work together because JavaScript will continue to come through the same pipeline. It'll meet up with the WebAssembly at the bottom layer there, and it'll just work within your application. So all of this is is why modern browsers today can support this so quickly, because the pipeline was sort of already there and you're just plugging into it. So what about Mono? So I don't know, some of you are probably familiar with the fact that Mono has this affiliation with WebAssembly, at least in the Microsoft world. So the fact is, in order to run C# in the browser, you need a .NET runtime, right? You need a .NET runtime that runs in the browser that's been compiled as WebAssembly. So when Steve Sanderson initially did his proof of concept for NDC Oslo, there was an open source project called .NET Anywhere, which he used initially, which was a really small footprint. It was a full .NET runtime, but it had been optimized. It was actually written in C, and it had been written more specifically for smaller devices, right? Devices that don't have a lot of memory or resources available. He used that and was able to actually fully demonstrate this concept of writing C# code, running it on .NET Anywhere, and running it in the browser. Found out that it didn't really scale very well because of some of the limitations of .NET Anywhere. And so then Microsoft said, OK, well, what else can we use? .NET Core is open source, but .NET Core was never optimized for this scenario either. Turned out that Microsoft also owns another very popular .NET runtime called Mono. They acquired it when they acquired Xamarin. And the Mono team had actually already been working on porting Mono to, or compiling it as a WebAssembly version. So that's the version that's being used today. So there's a version of Mono, which is a full .NET runtime, basically .NET Standard 2.0. That's been compiled to WebAssembly, and that's what Blazor uses. So how does this actually work? So on the server side, you build Razor code, just like standard Razor. That's part of .NET Core. And you can combine that with, obviously, C#-based classes. You compile those to just standard assemblies, right? Standard .NET assemblies. When you run a client-side Blazor application, it downloads some JavaScript files. Those JavaScript files know how to pull your application DLL across. So it actually downloads your application DLL from the server. It actually also downloads mono.wasm, which is the .NET runtime that's been compiled to WebAssembly. It knows how to interpret normal .NET DLLs. So it'll pull down your apps DLL and as well as any extra libraries that might be part of .NET that you need. So all of that is transferred over to the browser and spun up in the runtime, and that basically forms your fully functional Blazor application. So all of that stuff is running in the browser at that point. So I guess the next question is, why even do this? Why is this even relevant? Because we've got JavaScript, which has been around a long time. It's the most popular web development language out there. And then you've also got a lot of front-end frameworks like Angular and React and Vue and Ember. And I mean, there's a ton of them. A lot of them are very rich in their functionality that they provide now. There's a lot of very powerful enterprise applications that are built on them. So why would we want to consider this? I'm going to put this up here. Don't get offended. I think JavaScript sucks to some people. JavaScript is excellent for other people. Depending on where your perspective was. So if you were a traditional back-end C# developer and you've been forced to kind of learn JavaScript and you don't really, or you appreciate some of the things that C# had to offer that are not available in JavaScript, then maybe this is true to you. However, if you came from the other side and you maybe started developing more front-end and then you've sort of backed into doing some back-end stuff, this would obviously not be true for you. And maybe in that case, Blazor might not be all that interesting to you. Or maybe it is, because there are some scenarios where it still can be quite useful. So what are some of the benefits of running .NET in the browser? So you've got stability and consistency across your tool set, across technologies that you're using. So rather than having to context switch between a lot of different languages, between the different layers of your application, wouldn't it be great if you could build back-end in C# and front-end in C#, as long as it was capable of handling all of your requirements? More modern languages like C# and others that are type-safe and have all of that richness that are built into them have some benefits that we've come to appreciate over time. So those would be benefits. You could build Blazor applications using C# as opposed to building single-page applications in JavaScript. So you can use your tools that you're familiar with. Obviously, over time, tools like Visual Studio, VS Code, and others have built in better sort of, I guess, first-class citizen support for JavaScript, but mainly they were developed in the first place as more C#, native back-end type of languages. So that's another benefit. And .NET, especially .NET Core, there's a lot of emphasis on performance. That's one of the biggest, I think, benefits of .NET Core is they're continuing to optimize it to make sure it's as fast as possible. And there is a lot of friction lately, or maybe a lot of criticism lately about the state of front-end JavaScript frameworks. Because of the fact that they've evolved a lot over time and they're very powerful, some of them have a lot of baggage. I don't know if you've ever created a Hello World app in like Angular or something and realized just how many JavaScript files are part of that, like just basic applications. So there is some pushback or some friction around the state of front-end JavaScript frameworks, and perhaps Blazor is a way to deal with that problem. So there's some challenges to this as well. And these challenges are the reason why Microsoft is not shipping the client-side version of Blazor in September. The main one is on here, so Mono itself, it relies on Mono. Mono was never really optimized for this purpose as a runtime. It's cool that it can be compiled to WebAssembly and it works, but it needs a lot of further optimizations. And I guess the team that works on Mono needs some extra time to get it ready for prime time. Mono currently only supports .NET Standard 2. That's not really a big drawback, but I mean, if you wanted to use some of the things that are even further ahead than .NET Standard 2, then it's going to take some time to add them. The biggest one here, download sizes, is very large. So like I said or described in that diagram, when you run a Blazor application, it is downloading the runtime as well as all these DLLs down to the browser. So if you can imagine, and if they're not optimized, that's a lot of data that or information that has to be transferred over to the browser. So I mean, you could imagine like the first page hit, like when you spin up a Blazor application and it has to go and retrieve all of those DLLs, it's going to appear to be very slow. Like you're going to be sitting there waiting. And then once the application comes up, it's going to be fine because it's going to cache those DLLs in the browser. But that first spin up experience is very bad right now. Like there's no doubt about it. If you build a Blazor app right now, and if you can imagine, so even locally there's some slowness, like sluggishness to it. But if you can imagine actually running this in the wild with those DLLs sitting on a server and your client somewhere else and the latency of pulling down all of those bits, like this is a big problem, and Microsoft is trying to figure out how to fix it, meaning they're going to create probably a more optimized runtime version of, I guess, probably of Mono that will try to solve some of these problems. So to really reduce that footprint down quite significantly. They talked about this at the MVP Summit, about some of the things that they're doing to optimize this. And so I know it's something that they're focused on. And so for these reasons, it's not being released in September. It's going to be more likely December.
What about the memory footprint on the browser?
So yes, that's another problem. So it all comes down to the size of these DLLs. They have to be compressed in some way so that they take less time to download and they take less room on the client, like when in the browser. So that brings us to server-side Blazor. So this is the other hosting model that you can use for building web applications using Blazor. So cool thing is, exact same development model. So you build Razor components exactly the same way as you would for the client. However, it uses a server-side hosting model. So in this case, when you're running it this way, you're not using WebAssembly at all. The actual DLLs are staying on the server. They're running on the server just like a traditional server application. The communication that's happening between the browser and the server is being done by SignalR. So probably most of us have had some experience with SignalR over time. It wasn't even that long ago that Microsoft finally came out with the .NET Core version of SignalR. but it's SignalR that's going to be used for the communication in this model. So if you look at the diagram for this, you've got some basic stuff on the browser, right? Your HTML, you've got some JavaScript there. The server.js, or blazor.server.js file, all it's doing is establishing the SignalR connection for you. And then basically everything else is running on the server. So it's an alternate hosting model. It has some benefits. So it still can feel like a single page application. And it does this by doing sort of differential updates to the user interface. So it keeps track of, well, I'm going to explain this in a minute in more detail, but basically it's not doing full page refreshes. So because of that, it feels more responsive and it feels more like a single page application than like traditional MVC or web forms. It has a much smaller app download size because it's only downloading more basic web resources like JavaScript files and things like that. It's not pulling down all the DLLs. It has full access to .NET Core APIs, so it's not restricted to .NET Standard. Right? It can use the full richness of .NET Core. The debugging support is a huge one here. So, and I didn't really mention this for the client side, but in Visual Studio or VS Code, Microsoft is working on the debug experience for client-side Blazor, but in server-side Blazor, it just works already because it's a server-side development model, and that's what Visual Studio already understands. So you can like build your Razor code, put a breakpoint in it, and step into it because it's on the server. I mean, that all just works perfectly well today. So this is another reason I think why they wanted to make sure for client-side Blazor the tooling support was good before they released it as a real product, whereas server-side it already works. If you have legacy browsers, so browsers that are not considered modern, like IE11 or others, you can't really, well, you can run WebAssembly, but you need polyfill support, so you have to download extra JavaScript files to try and make up for the difference in functionality. But in the server-side model, because you're not using WebAssembly at all, you can build Blazor applications and run them on the server, and they'll work just fine, even on really basic older browsers. And so this is the supported model in September. So if you want to build Blazor applications, the officially runtime supported version will be server-side model in September. So challenges. So there's still challenges to the server-side model, right? There's never like the perfect world. So there's always pros and cons. So the disadvantages of server-side Blazor are that you're relying on SignalR. So there still is, and most of you understand, I think, the characteristics of SignalR is you have to maintain a SignalR connection between the client and the server. So it's not fully stateless, I guess you could say, right? It actually has to try and maintain a connection. If that connection drops, it has to try and reestablish the connection. And in that case, perhaps some of the state that you had is gone. So then it has to figure out how to deal with that. So there's some differences to the way that this works, which, well, and plus the latency, right? If you've got a constant connection, you've got constant, it's a bit more chatty. So running in this server-side model, your application would be more chatty than it would be if you were using a front-end JavaScript framework like React or Angular, where most of the processing is still being done on the client, and you're only calling back to the server to get data. This model, you're calling back to the server to get UI updates. So that's a lot more chatty. No offline support. I don't know if this is a big one if you're building like websites, but if you were building something like a game and you wanted to have it run in the browser and you didn't have a whole lot of interaction, or maybe you didn't have anything that needed to go back to the server. In the client-side Blazor model, you could actually build that. You could build an application that's fully designed to run in the browser with no other dependencies. This model, obviously, you can't. So server-side Blazor, you always have to have that server connection. Scalability, I haven't seen any hard data yet to show what the scalability constraints might be, but it is based on SignalR, which means that there's some limit to the number of SignalR connections that you can have open at any given time. And then at that point, you're going to have some kind of a scale-out strategy. Microsoft does have the Azure SignalR service designed for this purpose. You should be able to run a standard Blazor application even in just a standard Azure site service, right? That'll support, but up to what level, I don't know. Like, I just don't know what the limitations might be. And this is where I was talking about some of the future opportunities. So it was pretty cool, actually, at the Microsoft MVP Summit. Steve Sanderson actually demonstrated these two different hosting models that are up here. So he basically had a single code base of Razor components, and he demonstrated how you could run it in 4 different scenarios. So obviously client and server, but he was also able to demonstrate it as a progressive web app, which might be a cool scenario for building mobile apps, and also as an Electron desktop app. So it looked exactly like a desktop app with, you know, the file menu and edit and all that, but it was actually running a Blazor component, but it felt just like a standard like desktop app. I don't know how many of you have played with Electron, but it's like a, you know, cross-platform desktop application environment. And actually, I think VS Code is built on Electron. Mm-hmm. Yeah, so that's like in the Microsoft world. That would be a great example of an Electron app. So those are all future opportunities. I wouldn't expect like Microsoft's going to support any of these kind of hosting models for a while because they have to support the 2 main ones. But you can see how this Razor component concept has a lot of extra opportunities that are available to it. And I'm sure there'll be more things that come up over time. So some of the fundamentals of Blazor I'll cover. So I think what Microsoft basically did is, if you're considering creating your own single-page application framework, there's certain basic things that you need that are present in Angular, React, and all of the other ones. Things like routing, right? Some kind of layout support for your pages. Data binding, so one-way / two-way data binding. Events that you can, you know, react to user interactions. Dependency injection. That's just, I think, more of a .NET Core thing. Everything in .NET Core is now using dependency injection. And then the last one, JavaScript Interop. I don't know if that's necessarily a part of other frameworks because they are native JavaScript, so they don't need kind of an interop model. But this is quite a powerful part of Blazor, this interop model. Today, if you want to actually start playing with Blazor, it's become a little bit easier than it was when they first introduced it. At least it's now an integrated part of .NET Core 3. So, I mean, you can download .NET Core 3, any of the more recent previews, and Blazor is part of it at least. Previously, it was like a separate download. This is a bit confusing. So Microsoft released Visual Studio 2019 a couple months ago. So you'd assume that the latest version of Visual Studio is the one you should use for Blazor. Nope, doesn't work. So you got to actually download and run the preview version of Visual Studio 2019 for it to work properly. I don't know what happened. Obviously, like this was a mistake on their part. But that is something to pay attention to if you want to play with Blazor. There's also a Blazor extension in the Visual Studio Marketplace that you have to download as well. So it's like 3 different components that you sort of need to get started. And then this last one, this is just, so within Visual Studio 2019, there's like, in the options area, by default, it doesn't enable you to use previews of .NET Core SDKs. I think that's so that when you're building normal applications and you have NuGet references, it's not going to pull down things that are sort of unreleased. So it protects you from pulling down wrong things and updating your environment. But when you're building Blazor applications, you need those preview bits. So you have to enable that. So this whole concept, like the whole development model of Blazor, is based around the concept of Razor components. And so Razor components are just small pieces of UI logic that could be forms, part of your page, but they're basically smaller chunks of your application that represent something that needs to be rendered in the user interface. They're designed to be quite flexible, so you can have them nested within each other. They can have communication between one another. But the cool thing here, and this is, I guess, sort of a bit of a sidetrack, but so after Web Forms was released by Microsoft, and obviously the next thing that came along was MVC, MVC never really had the same component concept as Web Forms. And that's why the third-party ecosystem around MVC never developed in the same way that Web Forms did. Like in Web Forms, you've got all these rich vendors like Telerik and DevExpress and Infragistics and all these like rich tool sets, right? And we all used those tools to build user interfaces and things. MVC has some limited tools in that space, but it doesn't really have a component model, not in the same way. Microsoft's tried to introduce some things over time with like partial layouts and things like that, but it's not really the same functionality. I had complained to Microsoft about that like a long time ago and said like the MVC doesn't seem to be a natural fit for like a CMS, which is more dynamic and needs the concept of like components. Scott Hunter actually from Microsoft agreed with me, and he said that he was hoping that someday they would have something that would work better. So he's the one who actually reached out to me in November and said, have you looked at Blazor yet? This has a component model, which I think is exactly what you might need to build something like a CMS. I'm like, OK, I'll take a look at it. Initially, when I looked at it, I was like, OK, I don't see how it would work. So it required a lot more digging to try and figure out the dynamic aspects of it. But eventually, I was able to figure it out. So I don't know if this is not very clear, but the idea here is, of course, you write your code as Razor code. And then what happens in the background is it is compiled into component classes for you. So it basically compiles standard code into this other ugly looking, it's basically still C# code, but it's pretty ugly. And it's really verbose. Like if you can look over on this side, you'll see like it has to declaratively open an element for a p tag instead of like having just markup in your Razor. So it creates very verbose markup, but that's ultimately what Blazor can interpret, because that's ultimately what's going to be converted into WebAssembly. So that's how it basically works behind the scenes. If you ever want to sort of look under the covers to see how Blazor works, you can look in the OBJ folder under your app, and you can actually look at some of the compiled classes there. They have a weird name, so .razor.g.cs. So those are like the temporary files it creates for you. So component rendering. So we talked a little bit about this, but how does it actually work? So you got your C# Razor code. In Blazor, everything is built around the concept of a render tree. And if we actually go back here, you can see build render tree on that side there. That's this method, override build render tree. So everything's built around a render tree. So components basically are built into this render tree concept. And then it still relies on JavaScript to do a comparison between the DOM, because basically Blazor itself does not talk directly to the DOM. It still has to talk, so that would be talking from the server to the client, right? That's really not possible. So it still does it through a JavaScript layer. So Blazor still has a JavaScript interpreter that basically compares the render tree that's on the server, well, actually, not always in the server, but in your application, to what's in the DOM. And it figures out what the differences are, and it applies those to the user interface. So instead of doing a full page refresh, it'll be more granular in doing the updates. If you click, let's say, a button in your code, it actually, again, is using JavaScript to send that event back to your C# class. And that's sort of all part of this JavaScript Interop story. So this is how it sort of simulates like a single page application model. In fact, a lot of the Angular actually works this way as well, in the way that it does refresh or page updates, right? It has the concept of doing a diff between the DOM and what your application has, and doing like differential updates. React does things a little bit differently, but conceptually it's the same idea. So when you're running client-side Blazor, all of this is running in the client. So you can see how this is still a pretty high-performant kind of model. One thing to keep in mind, though, is if you're running it on the server, this part of your application is running on the server, right? Your Razor files are on the server. And all of those lines that are pointing back and forth are SignalR communication that's going on. So you can see how chatty it could be, right? So every action that happens with your application has to go back to the server and back to the client. So the updates might be smaller, but there still is a lot of chattiness behind the scenes that's happening in a server-side Blazor model. So when you create components, they are declared very much just like any other HTML type of, I guess, element, right? So it's a familiar sort of HTML syntax that you use. You can define as many parameters as you want on these components. So they can accept parameters. So in this case, there's a parameter called title that's being declared statically, within the code. And it's getting picked up by this function block. And then it's going to be rendered between some h1 tags, right? So ultimately, that title component is going to be replaced at runtime by h1 and then wow and /h1. So that's sort of how components work in a very simplistic sense. It also supports client-side routing. So every major single-page application framework supports client-side routing. The different JavaScript frameworks obviously do it in slightly different ways. I would say that the routing that's available in Blazor is probably not as robust as the routing that's available in things like Angular and React. It doesn't support as many sort of patterns that have been built up over time for those other frameworks and their routes. The way it works today is pretty simplistic. So you have a page directive that you put at the top of your Razor file. And then you specify which route it's supposed to react to. And then at runtime, when you run this application, it actually iterates through all the different Razor components that are part of your application. And it builds a route table based on the routes that are declared. So it knows that if /counter is entered into the browser, it should render this exact component. So that's how it does the mapping between a route and a component. So it's pretty simplistic. When I sort of got in, this was actually my first roadblock when I thought about, OK, if I'm trying to build something that's like a CMS or a framework, how am I going to make this work? And I looked at this router, and it's super static. Like, I can't have developers like naming all of their routes in the code. That's not going to work. It has to be way more dynamic than that. So the default router totally doesn't work in the case that I came up with. But for typical, this is a very more simplistic kind of a case, I guess, for building applications in Blazor. Microsoft usually covers the most basic cases. And then as you get into more advanced cases, you have to kind of roll your own. So if you want to support the concept of a layout, so if you want to separate your your logic for your visual design from your back-end logic, they have this concept called layouts. So you'd have to inherit from layout component base. You'll notice that this has no @page directive because this itself is not a routable component, right? It doesn't respond to a route. It uses this @body tag to replace that particular region with a component at runtime. So it's a way that you can do sort of simplistic components. I wasn't really able to take advantage of this either. One-way data binding. So I'd say all frameworks today support at least one-way data binding. So the concept here is you declare variables in your function block, and then you reference them in your Razor code by using an syntax. And so that'll actually render the value of that particular variable in the output when it's output. It also supports two-way data binding as well. So you do that by having like an input element here, and you have the bind equals attribute that you attach to it, and then you point that at a specific variable that you've declared in your function. So in this case, we're binding that value 10 into that particular control. So when it's rendered, it's actually just going to have the value 10 in it initially. And then you've got also the concept of event binding. So if you've got a button, you can use the onClick event that's then going to wire itself up to a function that you declare in your code. So, and again, you use the syntax to define what the function's name is so that it can find it in the Razor code or in the C# code. So one of the big questions I think most people have is when they look at this, they go, why would I put my business logic along with my presentation logic in the same file? All of the examples from Microsoft for Razor so far show this, but there is a way that you can actually have separate files. So if you want to keep stuff separately, like have a code behind, like we do in like MVC or web forms, you can do it that way. It's just that none of the examples, for some reason, probably because it's simpler to just display it like this, but you can split it up. Dependency injection, first-class citizen in .NET Core. first-class citizen in Blazor. So you use the add inject. Obviously, you have to register your services in your, your startup before you can actually reference them here. But it's pretty simple. If you want to pull in a service, you just inject it into your Razor component and then reference it. It's kind of interesting here. So actually, I'll cover this in another slide. So JavaScript Interop. So like I was describing earlier with the way that the differential updates happen in the user interface, that's all sort of happens through JavaScript Interop. You can use this yourself to access. So let's say you want to, like in this case, I'm accessing a cookie that's using JavaScript, using a JavaScript function that was written. So I can call from my .NET code using this JS runtime, and I can call a JavaScript function that's been declared in a JavaScript file, and then use that value in my .NET code. So that's pretty powerful. If I want to more selectively maybe target a specific element in the DOM, I can have a JavaScript function that does that, and I can call it from my .NET code. So that's a couple different scenarios there. You can also call C# from JavaScript. So that's another, I don't have an example of that here, but that's another possibility. So if you are writing a lot of, maybe you're comfortable writing JavaScript code, but there's something that you want to maybe write as C#, you can write JavaScript that can call the C# and get results back. So you can, Interop works in both directions. So that opens up some kind of interesting opportunities as well. So the concept here is, everything that I've described so far is like you write one application using Razor components, and then you can theoretically run them in any of these hosting models, right? That's what it sounds like. It's not exactly that simple. For simple applications, that's true, but you still have to pay attention to the type of application and what it's doing internally. So I'll give you an example. So let's say you're building an application and it has a database. So typical business application. You could, if you were developing it in the server-side model, your Razor code that you write can actually just call the database. It's on the server. The database is there too. So, I mean, you can have server-to-server interaction very, very easily, right? You can write entity framework, EF core code that calls the database, gets data back, and uses it. However, then if you tried to then run that same application in the client, it can't access the database directly, right? It would just fail. It would say, I don't even know. It would just throw an error. So you have to pay attention to what you're doing. There might be scenarios where you don't. So in the case where you're doing it in a client-side model, you of course have to write it so that it has an HTTP call, calls a web API, right? Which then calls the database, which basically sends back JSON, which is then handled on the client, right? That's the way it has to be done to run in the client, because it's a client-server application. But all that extra overhead of those different layers, if you only ever intended to run your application as a server-side Blazor application, you might not want to put all that in, because that would just add a bunch of extra layers that's slowing your application down. So you have to make these decisions based on the characteristics of your application. The application that I've been working on, from the start, I wanted to support both models. So I've had to write it really to support the client model, because the client model is the more separated model, right, where you have all of your layers more independently operating from one another. So you have to be careful there. I guess you have to pay attention to the different kind of methods, I guess, that you're using. So if you're writing a Blazor application and you take advantage of some of the APIs that are part of .NET Core 3, it's not going to work in the client-side mode, because that only supports Mono, which is .NET Standard 2. So you have to pay attention to that. Other things are, if you're running on the client side, you do not have access to a lot of system.io. Like, you don't have a file system on the browser that you can interact with, right? You can't save files there. You can't read files from there. That's only applicable on the server side. So if you were writing a Blazor app, you might do certain things to interact with files, and it would work. and then you try to put it on the client, and of course it's going to fail because it can't access those. So you do have to pay attention to exactly how your application is structured. HTTP client and JSON is an interesting area that I ran into. So client-side Blazor, Microsoft created basically a different version of HTTP client, which is designed to run in the browser. It has a similar look and feel as the HTTP client that works on the server. However, they've only exposed asynchronous methods because they basically say that they don't want anyone blocking UI threads when you're writing these Blazor applications. So you have to get used to writing everything as async for one. The second thing is for some reason, JSON.NET, which all of us are very familiar with, I guess, right? We all use JSON.NET for various things, does not work in client-side Blazor because internally it's used some obscure reflection kind of methods, which are not possible, I guess, to run in the browser. And so it's not possible to use JSON.NET. So Microsoft had to introduce a more simplistic JSON parser, which is specifically designed to run in the client-side model. But it's kind of simplistic. It's not as rich. It doesn't have as many capabilities as the JSON.NET does. So I don't know. Let me see how much time I got. 10 minutes? OK. So I guess, so demonstration. So some of you have heard of this. So I created what I'm calling a modular application framework. I definitely couldn't call it a CMS at this point. It depends on what your definition of CMS is. Some people just consider a CMS as an application that has some dynamic capabilities, right? That you can compose a page more dynamically. I would say a CMS has to have a whole lot more capability than that. Like DNN has a lot more than that. So I'm just calling it a framework at this point. It was inspired by DNN because of the early days when I first created DNN. It was a very simple framework. The main things that it had were a page compositing model that was dynamic, and it was multi-tenant. So those are things I wanted to make sure that I could try and replicate using Blazor. We also later, of course, introduced what we like skins, so designer-friendly skinning capabilities, so that you could have the skins completely separated from the application functionality, and that had that whole ecosystem, of course, that you're all familiar with. So I wanted to support that notion, or figure out if I could support that notion. And then the idea of modules that can be built independently and then plugged in. So that's the basics of, I guess, the framework. And I wanted to create something that was obviously open source. You're all familiar with, of course, the page compositing model that exists in DNN today, where you have the page theme/skin, sort of synonymous. You got your panes, where you define the different areas of your page where you want to inject content. You've got your modules, and then you've got your containers, right, which provide the administrative functionality for modules. So this model has worked quite well for a long time. So I'm like, you don't need to start over from scratch when you've got something that actually works. So this was the goal. Multi-site or multi-tenancy, based on the same kind of host name type model, or also supporting subfolders. So I wanted to try to create something that also had the same capabilities for multi-tenancy that DNN has. I also used the exact same query string kind of routing model because it's familiar, it works. I think that it could be improved upon, but I mean, it's a model which works for DNN quite well, so I thought I'll just take advantage of that and use that as well. And then I wanted, again, the data model for DNN has stood the test of time, at least the core of it has. So when you install DNN, yes, there's 140 tables, but if you actually dig into the internals of it, there's only around 20 tables which form the real core of DNN. So I thought, OK, why create a whole new data model if I could just take advantage of what's already in existence and works well? Of course, I don't need every single property that's in these tables today, because over time we've added a lot of things to DNN that perhaps aren't relevant for the newer world. Technical details, I had some technical goals I wanted to accomplish as well. So I wanted to support both client and server, which is sometimes a bit of a challenge. I knew I needed to create a custom router because the router that's part of Blazor is static, doesn't really work for us. Dynamic components, so all of the examples that you see for Blazor are very static in nature, and I needed to make sure that it was capable of injecting dynamic components. And then taking advantage of some of the newer stuff that the Blazor teams come out with. Cascading parameters is a way that you can define application state at the higher level, and it basically is inherited through all subsequent layers. It's kind of important in DNN because we've got like 5 layers deep once you get down to the module level. And so if you were trying to pass state from the very highest level down explicitly, it would be really painful and verbose. So I'm glad they introduced this. And I wanted to have, on the back end, at least like a more modern sort of headless API. Some of the other enhancements I wanted to introduce, so just simplification. So that comes as a no-brainer because I wasn't trying to convert DNN to this, right? I started from scratch and built it in a simplistic form from the ground up. So it is very much a simplification at this point. Naming conventions, I always sort of got tired that we got stuck with certain naming conventions from the very beginning, like tab. I have no idea, like that was from the very first iBuySpy stuff. Should be page, but like, so some of the naming conventions I wanted to fix, I guess, in the newer model. Although there's ramifications to that because people are very familiar with the names we have today. And so it would, it takes some thought process to think about the new names. I wanted to have auto module registration. So one of the things that was difficult for developers over time was this sort of direct dependency between your code and the database. So when you're developing modules, you as a new developer, you're used to just being able to write code and then run it. In DNN, you have to write code, then you have to register your module in the database so that the framework is aware that the module exists, then run it. That extra step is kind of confusing for people when they're just getting started. And so I did this in such a way that it actually uses reflection, and at startup, it figures out what modules are there, and they're just available automatically. There's no registration required. And then in the skinning side, I've noticed like over time that when you build skins or buy third-party skins, often you'll get all these different variants of skin files in the package. And realistically, they're all pretty much the same except for they have different pane layouts. And so it would be nice to be able to actually allow skinners to have, and the problem there is like as a skinner, then you have all these different files to maintain. If you have to make a change in one of them, you have to make a change in all of them, even if it's a trivial change. It's just a lot of extra maintenance. So the idea here was that you could have a pane layout that you would define. So basically it's like a component, which is like a region, which defines where all your panes are. And then you plug in a pane layout, and it could have all the different variants of pane layouts. But that would be a much smaller and more simplistic type of code to maintain, whereas the rest of it stays the same. You have one skin file. Yeah, so those were the main things. I guess, so Microsoft's been pretty good. I guess I was lucky. Scott Hunter, because he kind of encouraged me in this direction. I've had pretty direct interaction with Steve Sanderson, Daniel Roth over the last 3 or 4 months. When I ran into issues, I actually ran into some issues that were actually bugs in Blazor that just wouldn't work. And so I reported those back, and they fixed them. And so it's been pretty good from an iterative cycle working with the team. So they were quite happy when this actually finally got released, because I think they were getting tired of helping me, and it was still like a private application. And I released it on GitHub. And there's a website, a DNN site that I put up. So for now, I mean, what are the, I think David asked me yesterday, what are the goals for this? For now, I think, for me, I'm just learning about Blazor. I have to explicitly say this is not like what I would say is the future path for DNN. I think there's still some work to be done. It remains to be seen whether developers are even interested in this type of a model. I don't know if the server-side hosting model has serious performance implications to it. So I think until some more information becomes available, it's not something that you could make a decision today and say, we need to move ahead with Blazor, or we need to jump on Oqtane and start thinking about it. For now, if you just want to learn about Blazor, this might be a good place to get started. Similar to the way that web forms developers downloaded DNN just to see how you could do various things within that new framework. So that's the concept. I can show you, I guess, a little bit here, because I don't have a whole lot of time left. So the standard, can you guys see this? Probably not. Is it in options? Sorry, where is the?
You can use Control Plus or
Just make it
Control Wheel.
control wheel. How big do you want it?
That's good.
Okay, so this is the when you create a new application, so you can go File, New. This is obviously Visual Studio 2019 because it says Preview over here. That's the way you can know that you're running the right thing. So if we go File, New, how many of you have played with 2019 yet? All right. So those of you who have played with it know that the experience to create a new project has changed. It's got this new dialog that you get started with. So in my case, I would choose a .NET Core web application. The confusing thing for me is that it then asks you where you want it to be located, and it hasn't yet asked me what kind of a project I want to create, like what kind of a web application. But I'll just say yes to this, and I say create, and now it's going to ask me, OK, what do you want? There's a variety of different templates that are here. There's the Blazor server-side template, and then there's the Blazor. This is also, or both of these are client-side templates. So there's client-side hosted on ASP.NET Core, and then client-side that's basically not on ASP.NET Core, more cross-platform. I've already got an application. So if I want to back, the other thing, if you back out of that, you're not back where you started. I don't really like that. But so let's say Web Application 5. So back to where we were here. So this is a client-side Blazor application. In the www root folder, you can see there's an index.html file. Just like a Angular or a React app, you've got these, an app tag, and this is where the app is going to be injected when you run the application. Initially, it just says loading until it actually loads the app. And then it's got this script reference here, and it points to the blazor.webassembly.js, which is how, when you run a Blazor application client-side, it knows how to download the mono runtime and the various DLLs. Everything else in this application is pretty straightforward. So it's got like a layout. This is, again, this is the layout component. But you'll notice everything in this application is static. So if we look at nav menu, right, all of the links are hard-coded. There's no database as part of this sample app. It's pretty simplistic. It's got a few Razor components. It's got a component which we already saw the code for this earlier, but it just increments a counter based on a button click. It can load data. So if you run this application, it doesn't do a whole lot. It's running Bootstrap by default, so at least it has some decent styling that's included. So see loading, and then it loads the application for you. And as you click around, it's a fairly responsive experience. This is all running client-side. If I say click me, it actually is intercepting that button click event and then incrementing a counter. If you get a chance, because I don't want to take too much of Mandeep's time here. So this is Oqtane. You can get it on GitHub. It's the project set up in a little bit different way because it's a client-side Blazor project. It can be run in both scenarios. One thing to keep in mind, if you want to run it client-side, I've created some build configurations. So by default, if you choose debug or release, which is the standard, it would be running server-side. If you want to run it client-side, you choose Wasm, short for WebAssembly, and then you would build it. So it has a conditional compilation to figure that out. It's got a shared project, which is where a lot of the models are stored that are shared between the server and the client. On the server, it's got a whole set of API controllers for the different types of things that you would expect, like sites, pages, modules. It's got a repository pattern where that's how it gets the data. So I've tried to use more modern patterns as much as possible. And then on the client side, The most interesting folder to look in, I guess, would be the shared folder. This is where your router exists. So the site router is essentially the brain for the whole app. It has the incoming URL that it parses and figures out how to deal with it. And then it basically injects dynamically a whole bunch of components in a nested fashion. So you got the router, which injects like the skin or the theme, which was renamed. Mitch went and did all that work for me. And then within the theme, there's panes. And then within the pane, based on your database configuration, there's modules. And so it follows a very familiar pattern to what you're used to with DNN. If we run this, it's going to look, I started with the default template application that Microsoft provided. So it's going to look pretty much the same in terms of like the look and feel. But it has a lot more functionality. And it is actually dynamic because it's being driven from a database. So because I guess I was logged in previously, I'm logged in. Basically, the authentication story is kind of lacking. It's very simplistic. So there's a notion of a user. There is a login page, but there's not really much behind the scenes there. You can click around as an administrator, and you have this admin experience where you've got the ability, like the module actions menu exists, and you can go in and you can change settings. It has pop-ups for like modal dialogues for doing the administrative side, much like you have in DNN. If you hit the hamburger menu here, you've got, I guess, what you would call the administrative control panel, much like the, what is it called, persona bar kind of concept, right? Where you can add pages and add modules to pages. So yeah, so if you want to play around with it, it's all open source. It's all available. So you can check it out. And I better cut it off there.